Greetings to every one of you. So in this video we are going to discuss a very important concept from analysis of algorithm, that is how to calculate time and space complexities in algorithms. Here I have 4 algorithms, and let us see how this time function and space function can be calculated in all these 4 algorithms. Let us start with the first one, swap x comma y. You know that swap is a function that is available in some of the programming languages. It is nothing but interchanging the values between the variables. Okay, so the value of x will be copied in y and y will be copied in x. So for that we have used a temporary variable, that is temp. So this statement will be executed for one time. So it will take 1 unit of time. So here the unit of time may be a microsecond or millisecond or nanosecond, whatever it may be. So let us consider that 1 unit of time. So this statement will also take 1 unit of time. This is also take 1 unit of time. So total, in order to execute this 3 statement, so the computer will take 3 units of time. Okay, so this can be written as, that is the function of the time function can be written as order of 3. So number 3, it is constant. So this can be written as order of 1. So that is the minimum constant available in the complexity values. Okay, that is order of 1. Similarly, in order to calculate the space complexity, how to calculate the space complexity? So find out how many variables, memory variables you have used in this algorithm. So it is x, y, temp. So we have 3 variables, that is 1, 2, 3. So the function, that is s of n, space of n, can be written as, it is again order of 3. Okay, so as similar to the previous one, so this can also be written as, that is order of 1. So which is the minimum value, the minimum constant, right? So this is how to calculate the time and space complexity. Now I move on to the next algorithm with a loop. So here I am going to calculate a sum of set of numbers. So I have variable, that is x, it is an array. So yeah, initially is the output variable, that is s as 0, and here I have a loop. So the loop contain 3 parts. So one is the assignment of the initial value for the index, and this is the condition, and this is the incrementation of the index. So this statement will be executed for only one time, and again, whereas this one will be executed for n number of time. Consider the value of n in this loop is equal to 5, and whereas this one will be executed for n plus 1 number of time. So because initially the value of I is 0, the condition is checked here. If the condition is true, this statement will be executed. Okay, so first time I takes value 0, the statement is executed, then again I is equal to 1, it is incremented. Now the incrementation gets started, the incrementation gets activated. So the value of 0 becomes 1 and the condition is verified. If the condition is true, it will be executed. So that is I is equal to 2, I is equal to 3, I is equal to 4 and I is equal to 5. What happens? The condition become false. So at this stage the condition become false. So what happens if the value of n is 5 and this condition is checked for n plus 1 number of times. Okay, but again this statement will be executed for n times. So the loop, if you take a loop, and loop will be executed for n plus 1 number of times, and the statement below a loop will be executed for n times. That you have to remember. Okay, so let us find out what is the amount of the time complexity for executing this algorithm. So this is n plus 1 number of times, and this is executed for n time, and this is executed for 1 time, this is 1 time. So it is n plus 1, that is f of n is equal to n plus 1 then plus n. So we have one value here, one value here, that is plus 2. So it is nothing but 2n plus 3. So this is the time function. The time complexity for executing this algorithm, it is 2n plus 3. Okay. So what about this is space complexity? So in order to calculate the space complexity, you have to, that is take the variables. So how many variables are here? So x is a variable, n is a variable, and s is a variable, and I is a variable. So x, it is an array, so it contains, that is n number of elements, but n is a scalar variable, s is also a single variable, simple variable. So we have 3 simple variables, that is scalar variables. So totally we have, that is n plus 3. Okay. So n plus 3, s of n is equal to n plus 3. So we have to consider, whenever you are having the polynomial, you have to consider the maximum degree of the polynomial as the result. So Sn is equal to, it is nothing but order of n. And similarly the time function, that is f of n, it can be written as, it is the order of n. So here also you have to consider only the order, the maximum degree of n. Okay. So the maximum degree of this n is nothing but 1. So that is we have to consider n. So the time function f of n is equal to order of n, and the space complexity, the space function, that is s of n is equal to order of n. So similarly we can continue this for the other the algorithms. We have 2 more algorithms, that is one is matrix addition and another is matrix multiplication. Let us consider this matrix addition program. So we have the first one, we have a loop. Okay. So in order to, that is read a matrix, we need a loop. So the loop will be, as you know, that it will be, that is executed for n plus 1 number of times. Okay. So this is a statement that is below this loop, and this will be executed for n times. Okay. And this is a statement that is executed for again n times. But again this itself is a loop, so that will be, that is executed for n plus 1 number of times, and this is a statement that is below this loop, and this will be, that is executed for n number of times. Okay. This should be clear. Okay. Right from this loop. So these are the that is considered, these are the statement below this loop. So they will be, that is executed for n time, and this will be executed for n time. And again if you start with this itself is a loop, so this will be, that is executed for n plus 1 time, and this is a statement below this loop, and this will be, that is executed for n number of time, that is more. Okay. So we have the values. So this is n square, and here it is n square plus n, again it is n plus 1. So it is 2n square plus 2n plus 1. So you have to consider the maximum degree, it is nothing but 2. So the f of n, time function f of n, can be written as, it is order of n square. So the time complexity for this algorithm, it is order of n square. Okay. So consider the space complexity. How to calculate the space complexity? So we have the variables, that is the x, y, then c, and then we have n, I, j. So these are the other scalar variables we have. So this is a matrix, these 3 are the matrix. So it is n into n, it is a square matrix, consider it as a square matrix, it is n into n, so that is n square. This is also n square, this is n square. We have, what is that? We need n square number of, locations in order to store this value, this matrix, isn't it? Okay, this is a scalar variable, so 1, 1, this is also 1. So we have that is it is nothing but 3n square plus 3. you have to consider the maximum the degree. So S of n is equal to, that is order of again n square. Okay, is it clear? So this is time function and this is the space, time complexity and space complexity. It is nothing but the complexity is n square. Okay. Now I move on to the next the algorithm. It is matrix multiplication. So here similarly, here it is a loop. It will be that is executed for n plus 1 number of time. So it is a statement below this loop, that is it will be executed for n time, and similarly this is a statement executed for n time, and again this is also a statement executed for n time, and this is also a statement executed for n time. Okay, so all the statements that is under this loop executed for n times. Okay, now come to the second loop. This is a loop, itself a loop. It will be that is executed for n plus 1 number of time. Again all the other statements will be that is executed for another n time. Okay, is it clear? Understand? So then again we come to the third loop. It is a loop, so it will be executed for n plus 1 number of times, and this is a statement below this loop will be executed for another n times. So it is n cube, this is n cube. So here we have the n cube plus n square, that is the n cube plus n square, and this is another n square. So here we have n square plus n, and here we have n plus 1. So totally we have that is a 2n cube plus 3n square, then we have 2n plus 1. Okay, so we have this is the equation, final equation. So what is the maximum degree? The maximum degree is nothing but this n cube. So for this the time function, there is f of n, it is order of n cube, it is n cube. Similarly consider the space complexity. As far as space complexity concerned, we have the variables x, y, c, n, I, j, k. So these are the variables. So in this this is the matrix, all the these three are matrices. So n square, this is n square, this is n square, and all other things are the scalar variables. Consume there is one memory location. So this is 3n square plus 1, 2, 3, 4. So this is a function. This is the space complexity function for this algorithm, matrix multiplication. Okay, so the space complexity can be written as S of n is equal to the order of, you have to take the maximum degree, it is nothing but n square. So remember that for multiplication, matrix multiplication, the time function, the time complexity, it is order of n cube, but the space complexity, it is order of n square. So you just have given the values of the complexity, time complexity in the increasing order. So 1 log n, root n log n, n square, n cube, 2 power n, 2 power n power n, etc. So it starts from the function that is 1. For example, let us consider this is 1, right? It is a constant, it's nothing but constant. Okay, so that is why even if you get any that is a constant, we are omitting the constant because the constant it is equal to 1. Okay, so if you have a function like log n, so somewhere it will be here, it is a log n, and similarly root n, it will be that is here, root n, and we have the value that is n, and n log n, something that is greater than this value, n log n. Okay, so then n square, this is n square, and this is a n cube, and similarly we have that is 2 power n. So these are other things are becomes exponential functions. That is if you there is n square, it is a quadratic function. If n cube, it is a cubic function. So what will happen, see, every time if the value increases, the complexity value, that is increases like this. It will be like this. Okay, so I hope you understand how to calculate the time complexity and space complexity in algorithms. Thank you. Keep watching.